In this video, we'll show how to make a cluster computer out of multiple Raspberry Pi 3s to let you run an application against multiple processors. Here we've got 3 Raspberry Pi 3s, a USB hub, a Wago Ethernet switch, and power supply. We have 3 Ethernet cables and USB cables, as well as 8 GB micro SD cards for each node, and a USB reader. You'll want to download the Raspberry Jessie image and then insert the SD card for node 1 into your reader. And then using WinDisk Imager, write that image file to the first SD card. When that's done, insert that into the first Raspberry Pi and plug in a HDMI cable and a keyboard and mouse and apply power. And please bear with me with the shaky video here. I just want to show how you can go into the Raspberry Pi terminal and type in sudo raspi config. And we just need to make a few changes on the Raspberry Pi so we can operate the device headless. In the configuration utility, you want to expand the file system and then go into the boot options and make it load into console with the Pi user. And then go in and change the host name to node 1. Then we want to go into the memory split and make that 16 megabytes. And then the last thing is to turn on SSH. Then you can reboot the Raspberry Pi and everything else can be done through a console. So just do an if config and identify the DHCP address assigned. So here I've got a terminal on another computer and I'm just SSHing into that device. So we'll just start with a sudo apt-get update just to refresh the latest versions of all the programs. And we're going to create a folder called mpich, and we're just going to install the MPI packages, which are used for the message passing interface between the different computers. So just follow along and install these packages as shown. Now that the MPI is installed, we can install Fortran, and we'll just do that from sources. We'll download that file, and then we'll do a sudo make, and then a sudo make install. Now that Fortran's installed, we need to create an environmental path to the MPI folder. So we'll edit the bash rc and add the path as shown here. And we'll go ahead and reboot node 1, and then we'll test MPI by executing an MPI exec n1 hostname, and we should see node 1 respond, and it does. So now we can install the MPI 4 Pi, which is the Python application library. So we'll just install the Python dev, which is a prerequisite for the MPI 4 Pi, which we'll install now from sources. You can see the link there for the wget. And then we'll just untar that, and then we'll install that using Python. And once that install is complete, we just need to set the path for the Python libraries using the export command. And then we're ready to test our MPI for Python installation. There's a demo program that we can use for that. So we'll just type in the MPI exec n5 python hello world.py. So now that we know our image is good, we can remove power from node 1 and transfer that card back to the reader, and we're going to make a copy of that image file. We'll call it cluster_image.img file. And essentially we want to just duplicate this to the other 2 cards that we are going to use for nodes 2 and 3, and as many other nodes that you wanted to increase that to on your cluster. So I'm inserting node 2's SD card, and now I'm clicking write with the pointing to the image file that I just read off of the first node. Now we can put that card into node 2 and take the third blank SD card and insert that into the reader, and this will be node 3's card. Again, just clicking write. This can be somewhat time consuming. The 8 GB card takes a while. I've sped this up considerably. And with that third card in, now you can basically, using the HDMI cable and the keyboard, you can go into each node and power it up, and then using the ifconfig command, you can see what the IP address is for those. We can then just create terminal SSH consoles for those. We don't want to use we want to use a static IP address, so you just edit the dhcpcd.conf file for each of the nodes, and that will assign a static IP address. You'll need to reboot the Pi and then log back in with a new IP address for each of these nodes as you go through changing the dynamic address over to a static IP address. So here I'm doing node 3, just sudo nano with the config file. So now that we've set all the static IP addresses, we need to go into each node and assign the correct host name. So use the raspi config utility in the advanced options under host name and change node 2 and node 3 to match what they are. Then we go into each device and edit the host file, and we want the IP address that we used to match the host name that we're using for each of the nodes. Do this for all of the nodes in your cluster. Then we can use the ping command to verify that it's now able to identify the node by its node name instead of an IP address. Now we can test the node names with our mpi exec command. So we'll make a folder called mpi test, and then we'll make a machine file which is a list of all of the nodes that we're going to test against. So once that's saved, we can go into the mpi exec /f to reference our file name that we just created, host name, and we should see all the 3 nodes respond. We don't, however, because nodes 2 and 3 failed verification. So what we need to do is find a way to make the master authenticate automatically with the slaves. So we'll use the SSH keygen for that, and we'll go into essentially each of the nodes, and we'll issue that SSH keygen command, and then we'll make a copy of that file that it creates, which is a id_rsa.pub, and then we'll copy that file to the master node, and then we'll authorize those keys. So now we can test that using SSH pi at node 2, and notice it goes straight to pi 2's command prompt. So we want to repeat that for the other nodes so that the master can easily execute commands on the other nodes without having to log in. So here I made a copy of node 3's key, and now I'm doing a secure copy over to node 1. So once you've created all those keys and copied them over to authenticate them, we're ready for the next step. Now we need to create a network share folder for all of the nodes. So we'll install NFS kernel server, and then we'll modify the exports to include the path to our new directory that we created called cloud. So we'll just add that with the as shown here, and then we can use chmod to change the attributes of that folder. Then we just want to reset the server, and we can test it out. So we'll go to node 2 and mount that, and it worked. We'll do a df-h, and you can see that it shows up there. And we'll do the same thing on node 3. Just make also a folder called cloud, and then just mount the share to that mount point. We want the nodes to auto mount that share, so we'll edit the fstab file as shown here. And we'll go ahead and reboot node 2 to verify that it worked. And it did work. So now we just need to repeat that process on all the other nodes. So here I'm just going in and editing node 3's fstab with the same command as before. And then again, want to reboot it and test to make sure that it did auto mount. So now that that's working, we're ready to test our cluster. And we'll use that same MPI exec host name to see all 3 nodes respond. We just need to spawn 3 instances because we have 3 nodes. And here I'm specifying the 3 nodes explicitly, and they all are responding, which is a good sign. So now to test the MPI4Py, which is a Python implementation. So we'll edit our Python script, and we're going to get the rank, size, and name from each processor. So we'll edit the machine file. The Raspberry Pi actually has 4 cores, so we'll change that to reflect it. And then we'll use that same MPI exec command. So you can see all 3 nodes have responded with 4 processes each. So our program is working great. I hope you've enjoyed this video. I think it's an easy way to get started with cluster computing and learning MPI. Thanks.